So this theorem is called the intermediate value theorem. Let's think for 1 second about what the word intermediate means. You have beginner and you have advanced and you have intermediate. So what does intermediate mean? In the middle, okay? Mathematicians are not very creative people. They name everything exactly what it sounds like, or it's named after a person, like Cole's theorem, okay? Intermediate value theorem means you have something in between. So just remember, it is what it sounds like. So it says, if a function is continuous, I want you to like highlight that or underline it or put stars next to it or something, because that's the crux of the whole thing. If the function is not continuous, the theorem goes out the window. You can't even use it. Continuous on an interval A to B, C is in between. In between means in the middle. That's what intermediate means. The other two outputs, f of A and f of B. Then there is a value x such that f of x equals c. And it looks like the alphabet threw up on your paper. So what I always do is I draw a picture so that you can understand what's actually going on, okay? So just draw yourself in axes and, you know, put like some sort of graph on there. It doesn't really matter. You can just draw a line or a swoop or something. So we have this interval A to B. I explain it with a picture because all those words don't make any sense. It looks like it's written in a foreign language, right? So I like to explain it with a picture. There's A, there's B. This point on the graph, the output would be f of A. You have A, and then the output is f of A. And then for B, when you find that on the graph, that output is f of B. So you have those 2 points, A, f of A, B, f of B. And the function is continuous. There aren't any holes or breaks or gaps or jumps or asymptotes or other emotional problems. Like you can trace it without lifting your pencil off the paper, okay? So the function is continuous. What it's saying is, and I know it won't show up real great, but I'll use another color. C is somewhere in between here. So we have a C value somewhere in between. It's saying then this X value has to exist. What the theorem is saying is this value must exist. And we use this theorem most commonly for proving that there has to be a zero. Follow me on this. If you have a positive number and a negative number and the function's continuous, what's got to be in between? A positive and a negative, and it's continuous. Zero has to be in between. So we use it very commonly for proving that there are zeros. Okay, so let's read through the first one. And this does involve writing. This is writing in math class. I'm sorry. Welcome to advanced mathematics, right? If f of x is continuous, it has to say that or you can't even do the problem, right? And I know you're all like, will it not say continuous? They're all going to say continuous, okay? Sorry. All right, if f of x is continuous and f of 3 equals 10, so you have the point 3 comma 10, f of 5 equals -7, is there a 0 on that interval 3 to 5? Well, here's the question. You've got 10 and you have -7. Is 0 in between those? Yes, 0 is in between 10 and -7. So the answer is yes. But justify means you've got to write a little sentence. And your sentence is always going to start since f of x is continuous. You have to mention that. Without that, the whole party's over. If the function's not continuous, you can't do anything. So you have to say that. All right. So since f of x is continuous and the other part of the whole problem is in between. You have to say in some capacity, 0 is in between these other two numbers. Here's the most succinct way to put it. -7 is the smaller one, so that's f of 5. 10 is the bigger one, so that's f of 3. And you put 0 in between them. You're saying 0 is bigger than the f of 5, but smaller than the f of 3. Now, a lot of people don't like that. If you're one of those people and you're like, Miss Cole, that really bothered me. I don't like anything about it. If you're a words person instead of a symbols person, here's the other way you can say it. Since f of x is continuous and 0 is in between f of 3 and f of 5. Do you see how I just wrote it in words instead of symbols? You open that again, we're gonna have a problem. Are you following me how these mean the same thing? Pick whichever one you like better. Okay? Symbols or words, all right? But since the function is continuous, and this is all true, here's your big conclusion. There is a 0 on the interval 3 to 5. That's what you're trying to prove in the first place, is that there is a 0 on the interval 3 to 5. And that's sort of a matter of like just repeating the problem back at itself. Do you see how it says, is there a 0 on 3 to 5? You're saying, well, there is a 0 on 3 to 5. But I always compare this to, you know how in English class, when they give you a prompt? All right, go ahead and flip over. So this time, instead of an actual function, you have a table. The function is continuous. It has to say that. On what intervals must there be a 0? This is hilarious when I'm like, on what intervals? And someone says 3. An interval is a span of numbers. So you can't just give a single answer. It's from here to here. So an interval involves 2 numbers, okay? So I want you to look at what's on there. On what intervals, from where to where, would there have to be a 0, do you think? 0 till... Well, you have to have the 2 that are next to each other. So 0 to 2 is correct. That's one of them. Why? Positive to negative. So 0's got to be in between. And I think I made it so there was one more. Why 6 to 8? Well, it goes from negative to positive. So you're going to say, since f of x is continuous, that's how your sentence is going to start. Since f of x is continuous, there is a 0 on 0 to 2 and 6 to 8. Because, and you can abbreviate because, that's fine. You can abbreviate lots of stuff. I don't really care if you abbreviate. Why did we pick those again? What was our reason? Or negative is positive. Now, you can either say because f of x changes from positive to negative or negative to positive. I feel like that's kind of a lot to write. That's correct. And that's actually the more thorough way to say it. But I'll accept because f of x changes sign. I'll accept that as an answer because that's a whole lot shorter than writing out like the whole paragraph. Continuous, you gave the answer and you said changes sign. All right, let's try one more. F of x is continuous. You have the point 2, 17 and 8, 9. Now, instead of a 0, I asked, is there 10 somewhere on the interval? So here's the question. Is 10 in between 17 and 9? Yes, 10 is in between those. So we're going to say yes. Since f of x is continuous and here's the shortest way to put it. 9 is the smaller one, that's f of 8. 17 is the bigger one, that's f of 2. And 10 is in between them. That's the shortest way to put it. That's like the least amount of writing. But again, if that bothered you, because again, a lot of people don't like the symbols, you can say it this way. 10 is in between f of 2 and f of 8. Do you see what I'm saying? Like, if you like words better than symbols, say that. It's like a teensy bit more writing, but some people like this better. So now what's our big conclusion? Since all this is true, there is a value where f of x equals 10 on the interval where to where. What was our interval? From where to where? Look back at the problem. You're kind of just repeating the problem. on 2 to 8. Always just reread the problem because you're kind of just repeating the problem back to itself.